Hi all, myself Srishti Khare from IET DAVV from Department of Electronics and Instrumentation. Today I'm going to present the topic time complexity. Before understanding time complexity, we will look into what is complexity. Complexity of an algorithm is a measure of the amount of time or space required by an algorithm by an input of given size n. See, for solving a problem, we have different solutions. But to know which solution is efficient, we need to understand how much time it takes and how much space it takes in the CPU memory. That measure is called complexity. Complexities are of two types, the time complexity and the space complexity. First, we will look into time complexity. What is time complexity? Simply, CPU time taken to process an algorithm is called time complexity. Now, we have different type of time complexities. Let's just take an example. We have a class of n student. I have given one pan in the class, but I don't know which student has the pan, and now I want that pan back. So, to solve this problem, I have various options. First option can be I go to each student and ask them if they had a pen. So, to do so, I will take a I will go to each student and I have to go n times. So, this can be written in algorithmic form like this, and the notation for this will be O of n. This is the notation to denote complexity, big O of n. Now, second option, what can I do is I go to each student, ask them if they had the pen. Also, ask the same student if he knows which student has the pen. In doing so, I need to ask two questions to each student. So, this will require two loops, and the time complexity is called quadratic time complexity. Notation for this would be n into n, or n square. Third option is, what can I do is I'll divide the students into half, group A, group B, and I'll go to each group and ask which group has the pan. Whosoever says yes, I will search the pan in that particular group. This type of time complexity is called logarithmic. For example, binary search. In binary search, we divide the whole array in two parts and then we search. So that is called logarithmic time complexity. Fourth type of time complexity is linear arithmetic. Example of linear arithmetic time complexity is merge sort. For any algorithm, there are three cases: best, worst, and average case. Let's take an example of linear search. Let's take an array A, number 0, 5, 6, 7. Now, to search any key in this array, we need to perform an algorithm. If the key to be searched is 8, say, then the time taken for this will be least and the time complexity will be equals to 1. This is called the best case time complexity. The case where the key is always present at the first base address. Second, if say the key is 10. Now, to search the key 10 in this array, we need to compare each address. So it will take the maximum time, and that would be the worst case for this array. Say that we have an array of n numbers, so the worst case complexity will be n. The third one is average time complexity. The third case is average time complexity. Average case is equal to all the possible case time upon the number of cases. Say we have n numbers in an array, so 1 plus 2 plus 3 up to n till total number of cases, that is n. So this can be simplified as this, and this is called the average case time complexity.